So the fluorescence and photosynthesis studies in particular are aimed at providing some baseline information for what one might define an upcoming change, if you would, in orchard design. We have been designing orchards and creating bidimensional or three-dimensional canopies, basically following a rule that was worked out and found to be quite good in the 60s and the 70s of the last century, whereby the highest light interception would give the highest yield. Where growers and orchardists were at the time, it made a lot of sense. But now, systems like the Tatura V are clearly harvesting a lot of light. Then one might say, where do we go next? And the next step might be different row orientations, different row inclinations, orchard covers with different materials to remove a certain amount of light. And when you do all of these things, then this will also allow us a different management of irrigation during the day and during the season, hopefully reducing the amount of water needed, which is very important for the sustainability of the fruit growing operations. The photosynthesis fluorescence instrument. This is a rather complicated piece of equipment, but very powerful. It allows us to measure simultaneously photosynthesis and transpiration, so the gas exchanges of the leaf, and also the fluorescence bit of the light phase of photosynthesis. The photosynthesis unit that we've been using in the trial comes from the department, but when it first arrived here at the lab, I could see that one crucial component was missing, which is this box here. This box houses a fluorometer. Thanks to the Vesky Foundation grant, we were able to actually purchase the fluorometer head that is now installed on the equipment. With this addition, the instrument really fulfills its potential for data collection. In this configuration, we are able to do the biochemistry of photosynthesis, that is, how much carbon dioxide is taken up by the leaf. We're also able to do the physics side of photosynthesis, that is, how many photons of those that the leaf has captured are actually being used in the photosynthetic process. Because, surprised to say, most people don't realize only less than 5% of the incoming light is actually used for photosynthesis, which means 95% and more the leaf has to deal with. The ways to deal with that excess energy are more than one, and in general there is too much energy and it will damage the leaves. This part of the instrument allows us to measure how much damage is occurring while the leaf is impinging on the light is impinging on the leaves. So it couldn't get any better than this. One could really say that. With the fluorometer addition, now this is one of the most capable instruments for this kind of studies in the orchard. So basically the leaf will be placed in this position, and then we will close this chamber. We're actually providing light of specified quality. There's red and blue because these are the colors that photosynthesis is driven by, and in the intensity that we want. So it is not as intense as it is coming from the sun at the moment, but it's way above the capacity of the leaves to handle it in photosynthesis. So we're providing more energy than is needed to give us full photosynthesis. One of the important things that we're achieving with this international effort is the model was developed in Italy. We're now collecting data that will allow us to test that model under Australian conditions, because if it will work here, then it's already good. If it will not work here, we can adjust the model to give us a response for the local conditions here. We developed in my lab a model that only needs the fluorescence data to tell us the photosynthesis, which is what we're interested in. With application of that model, we would not need this much time as needed for the photosynthesis measurement. And so we could proceed much faster. But not only that, a fluorometer, a portable fluorometer, technically is very feasible with today's technology at very low cost. Imagine a phone, a smartphone, which can tell you the amount of fluorescence from a leaf as you just present the phone to the leaf. This is where we think this work will lead us in not too long, and that will be a much powerful tool for the growers to be able to gauge the health of the tree and the capacity of the tree to perform to its maximum.